Hey everyone, it is a little bit like talking into a black box right now, so hopefully people can see and hear me all good.
Just speak into the void confidently. It's part of
Great.
the it's part of the
Part of the
program.
exercise.
Yeah.
All right. Well, thanks, Jed. And yeah, thanks everyone for the invitation. Been really excited to join today. I've been listening into all the other presentations today, and I'm going to be pulling in a lot of the content that I've seen also earlier. I think it'll tie in really well. But my name's Brianna Pagán. I work at one of the data centers. I'm the deputy manager at the Goddard Earth Sciences Data and Information Services Center at NASA, or JESDISC. And I always get the caveat when I give any sort of talk that I in no way represent the entirety of NASA. And if you want a more official take of things, happy to connect you with the right people. I'm just here to give my own perspectives around what it is to build community and what I think community could look like here at Cloud-Native Geospatial Foundation. So with that, I wanted to start with a quote that I've been reflecting on quite a bit the past few months. Community's really been at the center of where I've been thinking. And it's this quote by Bell Hooks where it says, "The intellectual tradition of the West is very individualistic. It's not community-based. The intellectual is often thought of as a person who is alone and cut off from the world. So I've had to practice being willing to leave the space of my study, to be in community, to work in community, and to be changed by community." And I wanted to open with this just as a reflection of, even the fact that I have to give a caveat before I speak because of the levels of bureaucracy that I deal with at something like NASA. I think when we talk about trying to function beyond just individuals and as an ecosystem, it can feel like a pretty radical act. And I'm really excited about the work that I think Cloud Native Geospatial Foundation is trying to do in order to community build. I think this could resonate with a lot of people. I've worked across lots of different industries at local government, international consulting firms, tech startups, research institutions, and I see the same patterns regardless of where I go. I think it's really systematic, this very individualistic point of view, and just a byproduct of living in a very capitalistic society where we kind of admire this brilliant lone wolf intellectual that's working on their own and really trying to keep things for themselves to assess, I think, sometimes even just monetary value. So I really want to encourage us to go forward and think of a new way of working more collaboratively together. I think technology that's just based in dominance and scale so far has not solved the climate crisis. So excited to give some use cases today of examples of where I see community has worked and maybe potential ways that we can grow together and be more interdependent. So first, I was reflecting on who is really part of this cloud native geospatial community. And I think our, niche industry is really unique that it touches on all types of entities, right? We have federal government, commercial, humanitarian, tech, academic. Just go ahead and look at all of the representation from different entities for just the speakers of this conference. And that makes us ask the question of what are the roles of these different community members? And if you were teaching, or sorry, if I was teaching you in one of my classes, or if you were on one of my teams here at NASA, I love doing these exercises where people are trying to find kind of their, what I call it, like a climate compass, right? Trying to figure out what are you good at, what can you sort of contribute to society, something like an ikigai. And I think companies would also benefit from doing this sort of exercise. And I want to go through some of these use cases today and really evaluate like what are the roles of coming together, both as individuals and also as representatives of different companies. So there are other existing forums that I think a lot of people on this call and joining this webinar have been a part of, but clearly something's missing. And so some examples I thought of where our community has tried to come together are things like OGC or ESIP, Phos4G, or Pangeo. And clearly just having, an annual domain-specific conference really isn't it. I think we can all pull on some personal use cases where we think something's missing. And I want to pull some examples from just my time at NASA over the next few slides. So I think an interesting aspect of our industry is that the geospatial data user community is really the one that's creating these tools and technology. So it's feeling like it's coming from a very bottom-up approach instead of top-down. And I'm going to give some examples of, I think, really good use cases that I've seen so far of this coming into action working at NASA. But before I do that, I think I need to give a little bit more context of just what it is that I do at NASA and really what is a data center at NASA. And so you'll see us throw around these acronyms like DACs. So the NASA DACs stand for our Distributed Active Archive Centers, and they were created to really process, archive, and distribute Earth observation data. This is a really pretty old graphic, but you can see DAC sort of being the center and being this translation piece from actually working with the missions themselves that collect the data and then distributing it to the internet. And so we consider ourselves science enablers and really being at the forefront of a different range of potential users and user communities. And an example of maybe a top-down mandate that did come through is our transition to the cloud. So, NASA and the other government entities were mandated to move to the cloud. And so our data has been transitioning to the cloud over the past 4 or 5 years. We are almost done in that process. But we've quickly realized that the data itself just being dumped in the cloud does not mean it's accessible. And really that mandate of moving to the cloud came with the understanding that this would improve accessibility to our users. We're also at a phase right now of transitioning our services. So how people are actually querying our data and doing any sort of processing. We're having the same transition phase of making that work in the cloud. And we have the benefit of working with UWG groups, or what we call user working groups, with end users that typically tend to be researchers, which I think there's a lot of caveats you can read into on that. And then also the satellite missions themselves. And so we get our direction from users. We had many people on both sides, both end users and the missions themselves, coming to us saying things, hey, I've heard of this new data format called ZAR. How can I use it? How can I leverage that in my research and my workflows? So it's really from those meetings that we sort of take a pulse of what is needed, and then we get our direction of what we can actually build at the data centers themselves. So when it comes to going to the cloud, NASA is not able to answer all these questions, right? When we talk about the different roles that different entities play, I don't think the government is going to be able to play a role of like an innovator in this space. I always give the example of at NASA to have a new GitHub repo created, it has to go through a new technology request, an NTR, and that takes about 4 months. And so I think the role in government in this, again, is not to innovate, but we have had to turn to the community for sort of answering these questions of how do we have these best practices moving to the cloud? And I'm going to go through some use cases where I think the community has really helped us answer this and just show the power of community. One example is leveraging cloud optimized formats or access patterns. Right? These were not developed in-house at all, right? These are community standards like COGS or ZAR. And I'm going to pull on working with the ZAR format as an example. So at my data center, we have a tool called Giovanni, which is basically a visualization and also time series aggregation tool, where we take some of our data collections, we standardize them in a specific way, and then we make it more accessible for the user to use. So we decided to leverage the ZAR data format when transitioning the data collections that are in the back end of Giovanni. But there was a lot of open questions. Again, we're government entities, so quality control really means a lot to us. And we needed some sort of stamp of approval that the metadata with these ZAR stores that we were going to distribute is meeting some green check mark. And so we reached out to the community and tried to understand what was going on with a GeoZar specification. And almost 2 years ago now, we started hosting these biweekly meetings, and it drew a pretty diverse crowd from all of these and even more entities at this point to try to really figure out what is this minimum metadata to create a geospatial specification for ZAR. Now we wanted to be, really community based, but we hit some roadblocks, I think, in terms of really decision making. And I think most importantly, we really lacked people who were willing to go ahead and try to implement something for a spec. And so to try to circumnavigate this, we decided to turn to OGC and become an official standards working group, or a SWIG. Now, this was really to answer our maybe lack of governance and being in just an open community, right? Trying to make decisions. And since going to OGC, I'm not sure that that really met our need. And where I've seen the most progress come is after events like Cloud-Native Geospatial Foundation co-hosted a czar sprint in New York earlier this year. It brought together these community members, but actually sitting down doing work in a sprint. And that's really the push that we needed. And I think this is clearly a role that CNG could play, where I'm not sure we needed bureaucracy. I think we just needed the correct forum to be able to get the correct people in the same room and have these sort of discussions. And I think a lot of this has been helpful for just having even a Cloud-Native Geospatial Foundation Slack. So before, if I wanted to figure out, what was going on in Open Data Cube, I would have to try to find their schedule, listen to OGC meetings. Now there's just a Slack page that I can go ahead and shoot people a message to try to understand how that work can be integrated in something like GeoZar. Other examples of this is for the generation of cloud optimized data. So tools like PangeoForge, which I love the tagline of these community curated data sets. So it goes to show you that if the data providers are not providing the data in a cloud optimized way, the end user community is going to figure it out themselves. And this is a project doing exactly that, converting these legacy data formats into an RCode data format, and it's entirely in the open, which is also something that you aren't seeing coming from a data provider like NASA side, right? You're just seeing the final end product. This is doing that conversion process out in the open, and I think this is really a valuable way forward and something that was created from the community after we've already created internal tools at NASA, basically trying to do the same thing. Another example that I'm really excited about, and hopefully you listened to the Virtualize-R demonstration earlier, I want to pick up one piece of Virtualize-R that I find most exciting, again, coming from a data provider perspective, is, Virtualize-R is potentially being able to bring OpenDAP sort of into the forefront again. So OpenDAP, for people who don't know, is a protocol that was way ahead of its time in terms of trying to more quickly access legacy format data sets. And there is now Cloud OpenDAP, which relies on files that are called DMRPP files. This is too in the weeds, but these are essentially sidecar files that you can think of very similar to something like Kerchunk. And the virtualization of DMRPP files allows us to really look at these data sets like a cube. And this is another great example of this was not coming from NASA, it's coming from the community. And OpenDAP is something that is already trusted and used within NASA. So this is much easier of a potential pivot for us to support rather than something brand new like Kerchunk. And it's just based off of people maybe not even knowing the terminology and that holding it back. But I also wanted to highlight just the number of contributors that are already helping this project. Whereas, OpenDAP, I think the experts in that are becoming fewer and fewer through time. And so when we talk about building resilient communities, I think this is a really great example coming from the users themselves with this need. Okay, so I touched on just a few highlights that I've seen so far wearing, again, this NASA hat. But I also want to talk about some examples and areas that I think we need growth and improvement to foster a better community in our industry. So first thing is really talking about the downsides of rapid developments and new paradigms. And so the downside of coming out with new, latest, greatest technology is that it's really difficult to integrate this in operational users like NASA. And the example I'm going to use is Ice Chunk from Earth Mover. So these conversation around trying to support, dynamically updated czar stores has been around for a while. And Earth Mover and their team has been working on this for a long time, coming to entities like NASA saying, we have a solution potentially for you. And this has been a major roadblock internally at NASA. So we do have public czar data stores available, but only for data sets that are not growing. So just data sets that have an end date, we've put them in czar and you can access. But data collections that are constantly being appended with new data, we have yet to make available because of the issue that Ice Chunk actually solves. But we could not quickly, pivot and try to acquire something like Ice Chunk. We just don't have the mechanisms. And so I think we've seen this with a few different examples, even asking questions like, what are the best practices in ARCO, right? A government entity, is trying to use taxpayer money responsibly. We are not the innovators. We're sort of taking a bit of a back seat here and trying to look at the community to answer these questions. Like, I don't know, should there be duplicate archives with a czar store, or can we leverage something like virtualized czar or reference chunk indices instead of making duplicate archives? These are all open questions that actually make it a bit difficult to uptake anything within the NASA ecosystem. And I can see the same conversation that will probably happen with embeddings and machine learning, right? Where now we're being approached saying, hey, NASA shouldn't, require embedding metadata to enable machine learning practices. Well, our first question is there a standard for that? How do we know this is going to be useful? What's the quality control? Things like that. But it is really exciting work being done by a lot of folks on this call that we want to be a part of, but just the downsides also of moving very quickly. And then the last example I'll give is things like data provenance and also understanding what's the right level of abstraction for our end users. So we have worked with entities like Google Earth Engine and Simon because, again, we know that if we're not being the best at distributing our data in a cloud optimized way, other entities are going to come in and do that. Google Earth Engine is a great example of that. And for that, we just want to ensure that there's good data provenance and that we can say this is a trustworthy replica data repository, but we have not really figured out those mechanisms. And when I say the right level of abstraction for users, I mean, there's an open conversation of federated compute hubs and what is it to actually make this data accessible for the end user. And we see initiatives like 2I2C or OpenScapes also being in that space. Really quickly, just wrapping up, I also want to say that we have some special considerations when we talk about equity and also solutions and practice in our industry. So I'm actually calling in from New Zealand. I just attended FOSS4G Oceania in Australia and left pretty inspired by what I've seen at that conference, but just wanted to put a nod out there that, when we talk about scaling and, making petabyte level data analysis possible, I had someone from this conference come up, Pacific Islander Indigenous, saying, hey, all these satellite data is great, but did you know that Sentinel-2 data actually isn't acquired for islands that are under 100 square kilometer radius? So like that was news to me, and it's something that we can forget if we don't actually foster a more inclusive and diverse space. So just to throw out there that this scalability also in our downstream applications has been quite elusive in terms of understanding the impact to an end user. This was also a person that was specializing in using satellite data for relocating people from sea level rise, which is the end use case that I think we all want to work towards, but really asking questions if that's where we're actually at as an industry. And the last slide, I'm just going to play a little clip. I'm not sure if the audio comes through, but this was just at a run that I had yesterday, listening to a rainforest of bird song. And it made me think of this book, Syntax and Sage, which I really recommend. And there's a passage that basically is highlighting that humans actually have adapted to listen to birdsong, and we use it as an indicator of diversity because more diverse ecosystems means that they're healthier. And so we actually listen for birdsong. It's something inherent to being human. And so we know that diversity and fostering community is the right way. And I think if you're on this call, you probably already believe that. I just want to, make a nod out there that a lot of this is connected. And yeah, I'm really excited to continue this conversation in our next session and learning how to continue building this community together.